Good morning, students. So the topic which is going on is the single phase semi-control converter PET DC separately excited motor drive. So in earlier video, we discussed about the what is the importance of DC drives and how the DC drive speed is controlled with the help of single phase converters, three phase converters, as well as the chopper control drives, and also started the single phase semi-control converter PET DC separately excited motor drive. So I will save the presentation here. Yes. So this is we are discussing. Unfortunately, video recording has cut off. So that is the reason I am once again taking another recording here. So as per this discussion, I think it's clear. It is the single phase semi-control converter PET DC separately excited motor drive, and along with its coordinate operation. So in earlier we are discussing about the description of the circuit. Description of the circuit consisting of what the circuit is having. So it is a single phase semi-control converter PET DC separately excited drive. The armature is to be excited with the help of a semi-control converter. Field is also excited with a semi-control converter if field control is necessary. If field control is not required, then you can use a direct supply so that only one field current will arise for us. And we are representing the coordinate. Actually, the drives are classified according to the coordinate operation. Yes. Here it is only indicated in the first coordinate. Yes. So in the first coordinate, particularly, the output voltage and output current both are positive. As long as the drive is to be operated, the energy is transferred from source to the load. Clear? So average output voltage is positive, average output current is positive, so that it gives the power developed, which is in first quadrant one. Yes. So while drawing the speed torque characteristics also, torque is directly proportional to current and speed is directly proportional to voltage. So therefore, V versus I characteristics occupies in first quadrant. Similarly, speed versus torque is also occupies first quadrant. Yes. So let us go for the principle of operation. Yes. After describing the circuit, let us have a principle of operation. It's continuous conduction. Continuous conduction. So actually, the principle of operation is going to be discussed in two modes of operation. One is the continuous mode of conduction. Another one is discontinuous mode of conduction. In our syllabus, actually, we are having only continuous conduction. Yes. So we will give much priority for the continuous conduction, and the discontinuous conduction is not required for us. Yes. So it is a single phase supply. Let the supply voltage is to be defined as, which is equal to Vs is equal to Vm sin omega t. Why? Because it is a AC quantity, it should have a both phase and magnitude. Phase and magnitude. So therefore, Vs is equal to Vm sin omega t. And you see the operation of the drive in the operation of the drive in continuous conduction mode. So let us see, the supply voltage is defined as Vm sin. So Vm is the maximum magnitude and sin omega t is the phase. Yes. So this is the sine waveform. This is the sine waveform. Clear? So as the supply voltage is a sinusoidal waveform, it is the alternating quantity. What the rectifier does, the AC supply is to be converted into DC supply. Yes. So here it is a semi-control converter. It has two control switches and two uncontrolled switches. So the two control switches are T1, T2, and two uncontrolled switches are D1, D2. Yes. So during the positive half cycle, you see here, during the positive half cycle, Is positive half cycle is from 0 to pi. Yes. So when the T1 is to be turns on, the D1 is automatically turns up, but T1, when you give the gate pulse to the T1, then only the T1 needs to be turns. Yes. So if you see here, so the instant at which the gate pulse is given to the instant at which the gate pulse is given to the thyristor T1 at alpha. Okay, this is the instant at which the gate pulse is given to the circuit. So resulting, what will happen? The supply is to be transferring through the phase T1 and armature of the circuit and D1 and negative. So as long as this supply is passing through the T1 and D1, the source voltage is equal to the load voltage. Source voltage is equal to the load voltage. Yes. So actually it is given in this fashion, but this is the way to represent. Yes, exactly from here onwards, what is the source is having in the same fashion you have to be represented here also. Exactly what the source is having, you have to keep here. That's better I think, instead of trying all these things like. Yes. And simultaneously the current is also flowing from source to the load. Yes. So during the positive half cycle, T1 and D1 conducts. During the positive half cycle, and T1 and D1 conducts, and VA is equal to output voltage is equal to VS. Output voltage is equal to VS, and the current is passing from source to the load. Is it or not? Yes. So at the instant of pi, so what will happen? At the instant of pi, the supply voltage has to be reversed, resulting IA tends to reverse. So this makes the prevailing diode comes into conduction. This makes the prevailing diode comes into conduction. Yes. So prevailing diode comes into conduction in the sense, up to now the rotating system is rotating with certain speed. Due to the supply voltage reverses, the prevailing diode will come into conduction, and the current path is transferring, instead of T1 D1 by, it transfers through the prevailing diode. Therefore, the motor terminals are shorted through the prevailing diode. Motor terminals are shorted through the prevailing diode, resulting the voltage across armature is equal to 0. The voltage across armature is equal to 0, but the current should maintain some magnitude. Yes. So here the discontinuous conduction is avoided with the help of the prevailing diode. Yes. So therefore, from alpha to pi plus alpha, how the current is to be conducting with the help of the T1 D1 plus the prevailing diode. Yes. So this will be continued based upon the drive capacity. And as usual, if alpha is fixed, pi plus alpha is also fixed. So pi plus alpha is the second thyristor pulse. So at the instant of pi plus alpha, you are giving the pulse to the second thyristor, resulting the second thyristor T2 will come into conduction along with the D2. Yes. So during the negative half cycle, the T2 and D2 will come into conduction in opposite direction, so that this makes the average output voltage across the armature is this one. So this will also say at the instant of 2 pi, the supply voltage again reverse. So resulting the prevailing diode again come into conduction, and the current should maintain by the prevailing. Yes. So this is the process, and this process is continuously repeating. Yes. So this one is the output voltage, and this one is the armature current. Yes. So what is the supply current? Supply current is equal to armature current when T1 D1 on and T2 D2 on. Yes. So the supply, if the source is a sinusoidal, the supply current is in a square wave nature. And from pi to pi plus alpha, I think no device is conducting. There is no current transfer from the source to the load. At that time, the motor will generate the the voltage, that voltage is shorted through the freewheeling diode. So that voltage becomes zero and current is up to now the drive is in rotating mode, resulting it has a certain current. Yes. So that current is prevails through the freewheeling diode. Yes. So this the characteristics of the separately the single phase semi control converter for DC separately excited, right? So the source voltage as usual you are taking, and the armature voltage across the armature, and voltage across the voltage across the armature, and the current through the armature, and the supply current. These three parameters. Yes. So these three parameters are more important for us. That is the reason we drawn these parameters. Yes. So after once you understand the waveforms in continuous conduction mode, what you can conclude it in the sense continuous conduction, in the sense the conduction is continuous. The conduction is continuous. That means that the current cannot comes to be zero value. The current can here voltage you can observe voltage is here is non-zero, here is zero. Here is non-zero, here is zero. Yes, but you can observe the magnitude of current. Current should maintain always constant, always a non-zero current. That means that the current cannot comes to be zero at any instant of the time. So this current is known as the continuous current. Continuous current. Even the supply current cannot transfer to the load, but the load has already in rotational condition. That's why due to the shorting through the freewheeling diode, it circulates this some current. That current makes the continuous conduction in the drive. Yes. So let us see. In a cycle of source voltage, T1 receives the pulse from alpha to pi. Yes. T1 receives the gate pulse during the positive half cycle from alpha to pi, and thyristor T2 receives the gate pulse from pi plus alpha to 2 pi. No doubt in this. Yes. So therefore, the motor voltage and current waveforms as shown. This the description belongs to the diagram. Yes. And then during the positive half cycle, yes, during the positive half cycle, what will happen? So during the positive half cycle, whenever you are giving a triggering pulse at the instant of alpha, the T1 will conduct. Yes. So T1 is in forward switch. That means that upper switch, and D1 is the corresponding lower switch. So the power is always passing, or the current will make a closed path through the one positive terminal and one negative terminal. So for example, T1 conducts, D2 there is no possibility for D to conduct. If T1 D1 conducting simultaneously, it should be a short circuit. That's why one upper switch is in forward positive supply, lower switch should be in negative supply. So like this, the current is formed in the closed path. Yes. So during positive half cycle, the motor connected to the supply voltage VS through the thyristor T1 and diode D1. Is it or not? Diode D1. Next, during this entire period of alpha to pi, the source voltage is equal to the load voltage. So Vs is equal to Va, that is alpha less than or equal to omega less than or equal to pi. Alpha less than or equal to omega t less than or equal to pi. Yes. And this can be also written as here VL is the load voltage. It has a loop equation of Vs is equal to IARA plus LA into DIA by dt plus EB. Yes. So in between the interval alpha less than or equal to omega t less than or equal to pi. This is the equation number 2. Yes. So beyond pi, already you know, beyond pi what will happen? Beyond pi, the voltage has to be changed. Voltage has to be changed instead of plus by minus, minus by plus. So this will makes the freewheeling diode come into conduction. Otherwise starts conducting, so that the current IA transferred through the freewheeling diode. IA transferred through the the freewheeling diode. So whenever the IA transfer through the freewheeling diode, in the sense the motor terminals are shorted. The motor terminals are shorted. For shorting, the voltage across the armature is zero, but current should be maintained. Whatever may be the current which is transferring through the freewheeling diode. That depends upon the drive capacity and the speed of the supply reverse. Yes. So during this period, phi less than or equal to omega t less than or equal to phi plus alpha. So in this interval, this interval is known as the freewheeling interval. In freewheeling interval, the motor terminals are shorted through the freewheeling, so that makes the voltage across the armature become zero. That is, the VA is equal to zero. So this can be making as equation VS is equal to zero, which is equal to IA RA plus LA DIA by DT plus EB. This is the equation number 3. Yes. So, and based, what about the phi plus alpha onwards, which is similar to that of the alpha plus alpha to pi? Is so during the negative half cycle. As usually, that we are giving the triggering pulse for T2, so that T2 D2 will come into conduction during the period from pi plus alpha to 2 pi, which is similar to T1 D1 in reverse direction, which is similar to T1 D1 in reverse direction. So therefore, the average output voltage, across the motor terminals is given by, see the equation. So VA is equal to 1 by pi. So the average voltage is taking for full cycle, it should be 0. That's why average output voltage is to be always taken for a half cycle. Yes. So VA is equal to 1 by pi integral alpha to pi Vm sin omega t d omega t. Why can't you not consider from pi to pi plus alpha, in the sense the average output voltage is equal to 0 from pi plus alpha, pi to pi plus alpha. Yes. So that is the reason VA is equal to 1 by pi integral alpha to pi Vm sin omega t. So here Vm is constant, Vm by pi, you make the integrate the sin omega t, it becomes the minus cos omega t, the limits of alpha to pi. So you can substitute the limits. So the average output voltage of a single phase semi-control converter fed drive is Vm by pi 1 plus cos alpha. This is the average output voltage equation. Yes. So equation number 1 is the supply voltage, Vs is equal to Vm sin omega t. Equation 2 is the T1 D1 conduction, and equation 3 is the freewheeling diode conduction, and equation 4 is the average output voltage of a drive, and that is to be considered from alpha to phi. Yes. And once average output voltage is given, what is the average output voltage? VA is equal to Vm by pi 1 plus cos alpha. VA is equal to Vm by pi 1 plus cos alpha. So once the average output voltage is known, then you can express the steady state speed. Yes. So what is the steady state speed? Yes. So this equation is already derived at the basic characteristics of DC separately excited. Yes. So N is equal to what? VA minus IA RA divided by K pi. Pi belongs to KV. K is the voltage constant and pi is the flux constant. Flux is directly proportional to IF. This equation already derived in the basic characteristics of the DC separately excited motor, which can be also written as, yes. So which can be also written as, what is the average output voltage just now we derived, which is the Vm by pi 1 plus cos alpha. Vm by pi 1 plus cos alpha. So substitute the average output voltage in this equation. This becomes the Vm by pi 1 plus cos alpha minus IA RA by K pi. Yes. So this here N is the mechanical parameter, IA is the electrical parameter. So speed torque equation, while for drawing the speed torque characteristics, you should change the magnitude of IA into the torque. Yes. So how it is possible? What is the relation between torque and armature current? But we know that torque is directly proportional to pi into Ia. Pi is the field current. Pi is also directly proportional to field current. Is so which is equal to remove the proportionality constant k into pi into Ia. Is and Ia is equal to T by k pi. Is so Ia is equal to T by k pi. K is the proportionality constant, and flux is, for separately excited motor, the flux is constant. Sometimes this can be treated as a constant k pi. Is so Ia is equal to, as per this relation, Ia is equal to T by k pi. So this can be substituted in the above equation so that the average speed is given. Why? Because this is the average parameters. Armature current is the torque, everything is the average parameters. So substituting these values in the speed equation, therefore you can achieve the average speed of the system. Is so the above equation can be modified as, so as usually n is equal to Vm by pi 1 plus cos alpha by k pi minus, so here denominator can be split into two terms. So instead of Ia by T by k pi, so therefore T into Ra by k pi whole square. This is the equation number 5. Is so the steady state speed has to be changed into average speed by substituting the average parameters such as armature current and torque. Is armature current exclusively. Is so this the average speed which is given. Is so in this equation the first term is, so Vm by pi 1 plus cos alpha by k pi represents the no load speed. Is so this is no load speed. Is it or not? No load speed in the sense the drive should not having any load. At that time armature current becomes 0. Is so that is the no load speed. Is and what about the second term? That is the speed drop produced by Ia and Ta. Speed drop produced by Ia and Ta. Yes, based upon this equation, we will go for the further, which is the speed torque characteristics of the DC separately excited motor. Is so you see here speed torque characteristics. Speed torque characteristics is so speed torque characteristics. Actually, this drive is a single coordinate. Otherwise, this drive is known as a first coordinate. Why? Because as long as the drive is operated, the average output voltage and current both are positive. Both are positive. That's why it occupies the entire operation within the first coordinate itself. Within the first coordinate itself. So at the time of drawing the speed torque characteristics also, the characteristics exclusively occupies in the first coordinate itself. Is so let us have a look on how the speed torque characteristics are to be drawing here. So in the before speed equation, it has a two terms. One is the no load speed, another one is the speed drop because of the torque and armature current. So no load speed can be getting, the load can be kept 0. Yes, that is possible. So the ideal no load speed is achieved. The ideal no load speed is achieved when Ia is equal to 0. Ia is equal to 0. So Ia is equal to 0 in the sense both thyristors are failed to fire. Failed to fire. That means that no thyristor is in conduction. So therefore, E should be greater than or equal to Vm when alpha is less than pi by 2, and E should be greater than or equal to Vm sine omega t when alpha is greater than pi by 2. Yes. So E is the back EMF, which should be greater or equal to maximum voltage when alpha is less than 90 degrees. Whereas E should be greater than or equal to Vm sine omega t when alpha is greater than pi by 2. Yes. So therefore the no load speeds are given by, see here, the no load speed in before speed equation here not represents the speed belongs to no load. So when you substitute the LU of 0 to pi by 2 in the before no load speed equation, it is the Vm by k pi, and it is the 2 Vm by k pi for pi by 2 less than or equal to alpha less than or equal to pi. Yes. So these two values are to be obtained from the before equation. Why? Because speeds are commenced from the no load speeds onwards. So that is the reason the no load speeds are calculating by keeping the armature current is equal to 0. At that time, no thyristor is in conduction. So that we should maintain the developed back EMF is greater than or equal to Vm based upon the firing angle. Yes. So let us see the characteristics of a speed versus the torque. Yes. So actually, while beginning of the drive, what I told that this is a first coordinate drive. All the semi-control converter drives are a single coordinate drives. Yes. So it is exclusively a single coordinate. That to first coordinate. That to first coordinate. So it should be in between the omega m motor speed in terms of angular velocity versus the torque in Newton meter. So both should be in mechanical quantities, speed and torque. What is the power developed in terms of the mechanical quantities? T into omega. Whereas power developed in electrical quantities, P equal to V into I. So voltage is equal to the speed and current is equal to the torque. Yes. So this the characteristics belongs to the speed versus torque curves of a single phase semi-control converter pad DC separately excited motor. Yes. So there are two no load speeds. You can observe here. Vm by k pi is the one no load speed, and another one is 2 Vm by k pi. This is the another. Yes. If alpha exceeds 90 degrees, what will happen? If alpha less than 90 degrees, what will happen? Yes. So you see the characteristics here. So current is 0. Current is 0. Current is directly proportional to the torque. Torque or current is 0 in the sense we can achieve the no load speeds Vm by k pi. Otherwise, 2 Vm by k pi for the firing angle 0 to 90 and 90 to 180. Yes. So you can draw the characteristics for what is the speed equation. We are having the speed equation has the average speed equation has a two terms. Yes. So for giving the different values of the it is the equation is also consisting of 1 plus cos alpha. So alpha is giving different values, and you can calculate the speed in terms of the torque, so that it gives the characteristics like this. See, it is as the torque increases, speed is to be decreases. Yes. So this is the initial torque. There onwards, it is to be reducing like this and maintaining constant for alpha is equal to 0, and alpha is equal to 90, alpha is equal to 120. Yes. But the thing is, you have to increase the alpha value from 0 to 180 degrees. There is no provision for having a negative values. No provision for having a negative values. Yes. So this dotted line, what the dotted line you are having, you can observe here. You can observe here. Yes. So this dotted line is separating the continuous mode of conduction as well as the discontinuous mode of conduction. So this dotted line, right side, you can observe the characteristics are stable. The characteristics are stable. So that's why you can treat it. This conduction is known as a continuous conduction. But the left side of this dotted line, you can see there is a huge variation of the characteristics. Huge variation of the characteristics. Yes. So this much of variation of the characteristics we can't entertain at any cost. So that's the reason. So this region is to be indicated as a discontinuous mode of conduction, and this region is indicated as a continuous mode of conduction. Is it or not? Yes. So this is indicated as a discontinuous mode of conduction, and this is indicated as a continuous mode of conduction. So this is what, in the sense, it is a boundary between a discontinuous conduction and continuous conduction. This should be separated by a critical speed. A critical speed. Yes. So we will discuss about what is the critical speed in later. So critical speed is one where it separates the discontinuous mode of conduction as well as the continuous mode of conduction. So this is the speed torque characteristics. Yes. So the speed torque characteristics always occupies in the first quadrant itself. There is no reversal of power is possible in this drive. So as long as the drive is operated, the power flows from source to the load only. There is no other option in this converter because it is a single phase semi control. The diode does not support the reversal of power flow. Is so this is about the speed torque characteristics. And see what we discussed, that is to be also kept here. The operation of the drive is in coordinate 1 only. The operation of the drive, particularly in coordinate 1, because of the voltage and current. Otherwise, speed or torque always positive throughout the operation of the drive. Yes. So the operation of the drive is in coordinate 1 only. The circuit is useful. Why this drive should not operate in fourth coordinate? Yes. So why should not operate in fourth coordinate in the sense? It is a semi-control converter. It does not support the reversal of power flow from load to the source. Power flow from only source to the load, but load to source, there is no possibility because of the semi-control converter. Yes. So let us see the plot between average output voltage versus alpha curve. Okay. So this can clearly explain the why this drive cannot operate in the fourth quadrant. Yes. Yes, you see here. So this is the average output voltage versus firing angle. Alpha is the firing angle. So firing angle has a range of 0 to pi by 2 and pi. Pi by 2 to pi. There are two ranges. So 0 to 180 degrees. 0 to 90 degrees is one half. 90 to 180 is the another half. So what is the average output voltage expression in the semi-control converter drive? VA is equal to Vm by pi 1 plus cos alpha. Vm by pi 1 plus cos alpha. You are giving the values from 0 to 180 degrees. The average output voltage should always positive. Should always positive. So that is the reason. See, at the alpha is equal to 0. Alpha is equal to 0. 1 plus 1, 2 Vm by pi. So Vm by pi 1 plus cos alpha. Alpha is equal to 0 in the sense it is cos alpha is 0 equal to 1. So 1 plus 1, 2. 2 Vm by pi is the maximum voltage which is available at the time of alpha is equal to 0. And there onwards, you have to increase the value of alpha. The average output voltage is gradually decreasing. Yes. So gradually decreasing and then reach it to the 0 value at the pi. Yes. So in this alpha versus VA versus alpha curve, we can clearly show that at any instant of the firing angle from 0 to pi, there is no provision for having a negative values. That is the reason for operating in the fourth quadrant, the speed is negative, torque is positive. But is it possible to have a negative speed, negative voltage? Nothing is available here. So that's why this drive is particularly restricted to a first quadrant only. And in this first quadrant, only positive voltage, positive current, positive speed, and positive torque are available. That's why it is treated as a first one. So this VA versus alpha curve is clearly supports our operation is only in first quadrant. Yes. So why can't this is not operated is in fourth quadrant in the sense you can see here. This is the single phase semi-control converter, one diode, one thyristor. VA is plus and minus. So as long as the supply is given, the power is transferring from source to the load only. Yes. So during the braking operation, that means that during the negative cycle operation, the power does not flow from load to the source. So why? Because it is a semi-control converter. It does not supposed to develop power cannot goes to the source. Yes? So that's why what will happen? The entire developed when the supply voltage is reverse, back EMF is reverse, speed is also reverse. So that is the reason the polarities of the load circuit has to be changed. Before that, in motoring operation, this is plus, this is minus. This is also plus, this is also minus. But when the supply voltage is reversed, immediately the speed is reverses and back EMF is reversed. So the motor acts as a generator and producing the braking operation. So braking operation, the motor acts as a generator producing the voltage. But the produced voltage does not, the produced power or voltage does not goes to the source because of the converter not allowing the operation, resulting the developed power is to be distributed within the armature circuit, as well as the converter circuit. Yes, so there may be sometimes the speeds are very high, over powers are to be developed that may be destroy the armature circuit as well as the converter circuit. So for any alpha, Vm is less than 0. So in this operation is also explains or supports our first coordinate operation, and why can't the drive cannot operate in the fourth coordinate is, so you see here the output voltage cannot be reversed. The output voltage cannot be reversed when coupled to an active load. Yes. So due to reversing the back EMF, the machine works as a generator and producing the braking torque. Since controlled rectifier cannot allow any reversal of voltage, otherwise any transformation of energy from load to the source, then it is the entire developed energy is observed in the armature circuit. So this process is known as the reverse voltage braking, or also known as the plugging. Yes. So you can restrict that developed power during the braking operation. Otherwise, there may be a problem for the armature circuit. Yes. So to avoid this problem, what can you do in the sense? You can go for the single phase fully controlled converter fed DC separately excited drive. Yes. So students, this is the operation. This is the operation belongs to the single phase semi-controlled converter fed DC separately excited drive. Yes. So in this, so what are the number of points we cover? First, you keep this side heading as single phase semi-controlled converter separately excited motor drive. Yes. So you can start with the single phase semi-controlled converter drive and its coordinate operation as shown, and then followed by the circuit drawing and coordinate operation, and followed by description of the circuit, and then the operation is explained in continuous conduction. So for explaining the continuous conduction, the waveforms are very supporting for us. Yes. And during the positive off cycle, what will happen? During the negative off cycle, what will happen? And based upon that voltages, how the average output voltage is to be derived, and based upon average output voltage, how the steady state speed and average speeds are to be derived. And once the average speed is getting in terms of the speed and torque, and how the speed torque characteristics are drawn, and how the explanation belongs to the speed torque characteristics, and why this drive can't allow any 4 coordinate operation except the first coordinate operation. So all these details, in addition to all those details, these two, lastly, the VA versus alpha curve as well as the braking operation, all these are to be clearly given in detail. Yes. So it is a very, 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 very good topic. So once you can understand this one, further all are same. Nothing is there. Once you understand thoroughly this one, either single phase or 3 phase, semi-controlled or fully controlled. Semi-controlled is a power flow is only from source to the load, but fully controlled converter is power flow is possible from source to the load as well as load to the source. So why you go for the fully controlled converter? In the sense, when the drawbacks in the semi-controlled converter are high, to overcome the drawbacks in the semi-controlled converter, we can approach the fully controlled converter. So this is the single phase semi-controlled converter fed DC separately excited drive. I hope all of you understand this topic. So any doubts, we will discuss. Okay. With this, I am stopping this lecture. So tomorrow onwards, we will go further the next topic.